Great. Yeah, so what we wanted to cover a little bit is I will go through the things that we released in Squid, just at a high level, the highlights, just in case anyone hasn't gone through them. And then Matt will cover like what's coming in the future now in Tentacle, the U release, etc. So we can go through those. Okay, so with Squid, like kind of the high-level features that were added. Regarding multisite, it was true that there's the object headers with replication status. So this is when you're working with multisite replication and you want to be sure that an object has been replicated. There are headers that you can query on the object and you will get headers on the status of the replication. The idea here is not really to go, like you use it for a monitoring stack to check all of the objects in all of the buckets, but it is very handy in a workflow of an application, in the logic. So you want to, you have an application, you want to take a decision once the object has been replicated, you can query the header, and then you can make the application move forward and continue as an example. No? There's also a per bucket audit login, so the S3 bucket login interface that I will cover a little bit in detail in a moment. Regarding multi-tenancy, there was the big thing of adding RGW, IAM accounts to really improve the multi-tenancy story in Ceph that I will also go through in a moment. There's also STS security improvements related to the Java Web Token, how the keys, the X5C keys there are read, etc. So there are improvements there. And finally, hybrid cloud integration. Here, I think previously like called cloud tiers. No? So when we want to push data, archive data from Ceph to a remote S3 endpoint, in the past we could only do this, we could only push. But if we wanted to pull from inside Ceph, that was not possible. And in Squid, we added a way to be able to also retrieve data from inside Ceph. So talking about these features, just very quickly, the S3 bucket login gives you like a self-service S3 endpoint like for the end user to be able to actually configure an audit log for himself for the bucket and without requiring any help from RGW admin team. So as an end user with the S3 endpoint, you can configure the destination bucket log, and there you can track all of the HTTP, all of the requests from the clients that are happening with your application in different buckets. No? So it's very handy in this sense. It can give you insights into how data is going in your application, how it's working. And it also has like another use case that is for backups and recovery in the sense that it has like a journal mode that is synchronous. So you have like a list of all of the modifications that have happened in that bucket, and that can be used by backup and restore applications to provide like incremental backups, no? Because then you have in the journal a list of the things that have changed since the last time that you took a backup, so you can improve the efficiency of your backups also with this feature. This is just an example, and you have a QR code if you would like to go into the details of how this was set up, but it's a use case for the S3 bucket login in the sense that we configure a destination bucket log, we have applications writing in production, and that's sending all of the data into the bucket log. And what we do is that with a SQL engine, like in this case Trino, that is able to query the data that is inside the bucket directly, we can build with Superset really nice dashboard that gives us insight in the traffic that is happening. We have here like request and latency per second, etc. So it's really a nice way to use the S3 bucket login as an example. And then very quickly with RGW accounts, this is like a really big one for multi-tenancy in RGW. No? So being able to delegate to a tenant and make him responsible for his chunk of resources inside object storage is really important. And all of this is done through the IAM API, so it's fully compatible with AWS and with any automation that goes around it, like Terraform, Ansible, etc. You can just plug it in and it's going to work because it's compatible with the IAM API. And here I just have an example, a little bit of the workflow of the RGW accounts, in the sense that you have there, like in kind of that strange orange color, what the Ceph administrator would do. As a Ceph administrator, RGW, I just need to worry about, I create an account, I assign it a set of resources, so I would assign it a quota, etc. And then I create like a root admin. That root admin user is the one that I'm going to give to the person responsible for the tenant, and then he can do the operations by himself. So he can create users, manage access keys, policies, OIDC providers for single sign-on, etc. And you can manage all of that at the tenant level, but through the through the S3 IAM endpoint, no? Without needing any special admin ops API or anything. You can do it through the endpoint. And finally, to go through the archival policy-based data archiving that we mentioned before. So as we said, in the past, we were able to push data into remote S3 endpoints. Here you have an example, for example, Amazon S3 or IBM Cloud. You also have like S3 tape endpoints that are becoming popular that you can use here. So here you have a lifecycle policy in your bucket. When X amount of days go by, you want to archive your data to cloud. You want to move it out. No? So in the past, we could push, but now we can also retrieve. No? So we are able to bring the data back to Ceph. We have like 2 ways of retrieving the data. You can use the restore object API. That is part of the Glacier API, by which you can asynchronously retrieve an object from the cloud, in this case from tape or from AWS. You can retrieve it into your Ceph cluster. Or if you prefer, there's also transparent read-through that you could configure. No? So in the sense that as soon as a client does a get into the stub file, the stub object that is in the bucket, is going to automatically bring it back from the remote endpoint. These restore modes can be temporary or permanent, so you can decide if you want to actually keep that object, or maybe you just bring it back for some kind of reason, for backup or whatever, and then you want to get rid of it. Yep, and that's a little bit moving into the Tentacle side of things. Do you want to continue, Matt? Or?
Sure, I'll do my best. My ability to read at this scale. We're doing. We've tried to break things out into a couple of areas, but I think things are landing in Tentacle. The biggest thing we're working on is there's been 2 talks about the related work here, but we're trying to scale bucket indexes. We're trying to scale buckets up to a 10 billion object range, which seems to be it's still safely a challenge scale, but there are real workloads that get there, and we need to hit it. So we're reorganizing the whole the notion of how bucket listings are organized and how they're related to the objects contained in buckets to achieve that, and we're far along with that. Beyond that. There's smaller things and more things coming in, past Tentacle. But in this cycle, we've implemented get caller identity and get account summary. Just 2 of the little pieces of the IAM SDS interface that we didn't have. The bigger stuff is coming, in the next release. We did implement some more observability stuff. Again, bigger things are coming after this, but for one of the longest, from what I can tell, one of the longest serving requests. So a couple of our key users at Red Hat and then now at IBM have had was the ability to easily understand the usage of individual users and by bucket, and to have that and had various unpleasant tooling to do that. So we've added that support to Prometheus in the Prometheus workflow in this release, and it'll be in our downstream release. And I think you've already mentioned some of essentially covered the 4th one. There was a second round of improvements to the object tiering. Yeah, improve like the asynchronous download of the objects.
But also I will mention very quickly that if you haven't gone into the dashboard in the last 6 to 8 months to a year, that happens quite a lot, I will challenge you to go and take a look at the dashboard and all of the improvements that have gone there, because, for example, for Object, there are loads of improvements for the feature set that we have in Object that have been pushed into the dashboard, and you can do it from there if you like.
Yeah, that's really true. And I don't use it enough, but we finally have an impressive user interface support, self-service, emerging as well. So we talked. So let's see. We talked about bucket in order sharding. So I'm not quite sure what the distinction was there.
This one is
okay.
Right.
So I was skipping ahead. What we implemented in Tentacle was non-pausing reshard. So this came out. It's actually a contribution from upstream, and it makes it basically has a log-based update strategy where resharding is an operation, a log of the incoming ingest and changes is kept, and then that is run after the restart. The hypothetical restart completes. That transaction log is run. I think it can actually do multiple rounds of this until eventually it converges on the same, and then the bucket goes live with the new index. Anyway, but the work that Eric was describing and that Radoslav was debating earlier is this bucket index scaling stuff within order sharding and other stuff. There's a bunch of new potent work on IAM and STS coming. We're implementing customer managed policy, and which was one of the big gaps in our policy implementation to date. So people will be able to install a policy at runtime and bind it to specific accounts. They'll also be able to. We also are implementing the S3 control API for public access block, which means that which is the way that you disable all forms of read-only / public access to S3 buckets declaratively. We implement a whole bunch, and some of this stuff is in Tentacle, I'm afraid. But we implemented a whole bunch of this just on an accelerated basis. S3 conditional write, so a bunch of the conditional put modes, conditional multi-part put, and also conditional delete and conditional delete with bulk. These have a bunch of different modalities, and you can do all of that. So I guess it's nested here under, and surprised by this part. And you also are, this is weird, and I don't know how it's related. I'm not sure how it's related to conditional update and delete. But we are doing another round of work with S3 and NFS. If you've been hearing some of the noise from industry about how S3 and RDMA might work together to accelerate workloads, perhaps related to GPU offload, where we're streaming the contents of objects at high data rates. Our strategy for doing this at least we're experimenting with, is to do this with NFS over RDMA, which is already standardized as a form of GPU direct, and both NVIDIA and some other vendor workflows would be supported by this. So our way in and out of object for RDMA would be via NFS. We already have an NFS, converged NFS and S3 capability that can be used for a variety of scenarios. This would link it to RDMA. It's mostly a question of, our experimentation right now is mostly figuring out whether the current workflows that for example, GTS natively delivers can be supported. Our current semantics are kind of upload-like for writes, although they're arbitrary for reads. It probably just works, and if not, we have a roadmap for further integration of NFS and S3. And I guess finally, we're also implementing another long-standing request from a couple of our key users. Several of them actually was the ability to set quota and also report statistics by user and storage class. And as you saw, we're doing a lot more with storage classes in the last 2 years. So this is becoming increasingly important. So we committed to implement that. And a final thing, Gabi Ben-Hanak, working in Israel, has contributed a very capable, although compact form of deduplication. that links with the S3 object storage. It'll only deduplicate whole objects, but as I say, it's very capable and it's very efficient because it's as a two-pass construction where it uses the already calculated hashes of those objects and then maintains a bunch of stage processing to narrow those down. And it consolidates objects using the existing reference counting mechanism that's used for copy for low cost copy object and stuff like that inside the RGW server. So that'll be, it's upstream now, and it's going to be in a release in U. Okay. So I mentioned that we're doing some stuff with NFS over RDMA. And you'll be, so this is just NFS, except you're talking to your objects in S3. I'm not sure what the optimized performance is. We're constantly improving that stuff, what we're doing, but I don't know what the particular items here are. We are doing work. We are doing a bunch of performance measurement related to LM cache in S3. Kyle Bader can talk about that, and other data paths.
Yeah, no, this one was just for the NFS over LDMA, but
okay.
This is like the one with the future plans.
Okay. Well, what do you want to? So things that are in here. Some of them are old, and some are brand new. An old item work item that's been in progress for a number of years, and it's actually started by Radosov Sarzinski, who was speaking here before. We did a bunch of optimization to multi-site replication performance about 3 years ago. I guess it was roughly in that order. The very big, there were a lot of in the early days of our replication scheme. There was a lot of inefficiency related to the otherwise elegant transactional logging that we do. Some of the accounting for those logging updates was very costly. Work was on here. The biggest one was the sort of alerting system that tells you when. Basically, it's a sharded scheme, but a bunch of parallelism is enabled there, so you get a lot of parallel replication performance potentially. There was a lot of overhead in sending the alerts through what's called the data log. That was completely fixed, and it was changed by implementing a whole new mechanism called FIFO. It's a distributed data structure that spans a bunch of RADOS objects in concert, and it's sort of a double-ended simultaneous update delete queue. This was designed by Udasade. We didn't have time to finish doing the second part of the logging update, which has actually got the most of the data in it. Actually, for any given shard, all the transactions for a specific group of objects in a bucket. That remained in OMAP, and OMAP is not it's not a constant time operation to insert or delete. It's logarithmic time, so it's costly. This has now been prototyped to completion. And within the next several months, we expect to be able to merge this. This should further reduce the overhead of multi-site replication by a substantial amount. We haven't specifically measured it, but it's commensurably significant. So it should translate naively. It should translate to improved replication performance, but most importantly, probably it's going to give a lot of IOPS back to clusters on both ends of multi-site links. So that's a big deal. We're going to be releasing a prototype of the next generation of our cache, our materialized data cache. The first version is this is D4N. I think this was Data Center Delivery Network was sort of the DDN, and I'm giving a talk. Well, Jesse Williamson and I are going to talk a little bit about parts of that later. But there was a talk in Geneva about the core of D4N. But there was a precursor to D4N, which is D3N, which is a read cache. D4N is a write-back cache, and our goal for it in this release is to accelerate transactional workloads, stuff like Spark, and other things like that, where we're ingesting potentially other workloads where we're ingesting and deleting data, we're ingesting it rapidly, and serving it immediately to other applications. In this case, it'll be out of cache. And so for later write-back. So it gives you the ability to have a more flexible deployment of core RADOS services and RGW and an RGW tier, which can absorb additional workload, and it'll do more stuff. Plus which we think it's a gateway drug to more powerful integration of data center, data-intensive applications and S3. So, for example, we're over in the upper corner here for analytics and the analytics and data part. One of the big things we're doing here is if there's 3 of them here, but the top one is the biggest one. We're implementing a converged LansDB-based inference service inside of S3 using Amazon's S3 Vectors API. This is a complex capability, but there's a lot of natural affinity between what the S3 tier does and what a system like LansDB does. And by virtue of having something like D4N, we'll be able to have a converged 2-level cache for large data sets, so for indexes spanning many S3 objects and competing for space for workloads and concurrently. D4N becomes a building block for intelligently accelerating those kinds of workloads. Let's see what else was here. I think we mentioned some additional reporting by storage class. We're intending to. There's more tracking on. There's more stuff. There's more per storage class stuff. There's actually quota here. This is talking about general ops. I don't know. Is there actually a productized tracing capability here? There's been ongoing tracing for 5 years, but I think this refers to Jaeger tracing. This work on Jaeger tracing in Ceph continues. So we have the most of it, but apparently it's being added to the Cephfs MDS and maybe would it be added also to NVMe over Fabrics Gateway? I think someone could talk about that. But I was told that indirectly, but I think that's the case. We are planning. We have had in the roadmap. I don't know when this is going to be implemented. So I know. I see we're in the horizon now. S3 Vectors is coming ASAP, but this stuff is more horizon. We have plans to implement intelligent tiering, basically taking the storage class based tiering that of the different kinds we currently have, allowing some of the additional parameters that Amazon has incorporates for intelligent tiering, basically allowing data to be hotspotted and to be recovered based on temperature or other access rules. There's not a lot of them, but these are incremental steps that'll be useful. We will have in per storage class quotas and metrics. So I think it'd be easier if you go to the remaining ones.
Yeah. No, this is just going a little bit about when we were talking about IAM, like RGW accounts. What we see is that, okay, it's very nice to have multi-tenancy and self-service, but as kind of enterprise workloads, you also want to have certain control on what these accounts can do. So maybe you want to enforce some kind of policy. That's where customer managed policies come into place, where you can define different policies, but also especially like working with organizational units and service control policy, in the sense that you can push to the different accounts certain policy that you want to enforce on them. So that's also kind of a requirement that comes in the future. And then here we also see quite a lot people fighting with ACLs, in the sense that it's very easy to make a mistake and make those buckets publicly accessible. So trying to very easily control or remove or get rid of ACLs, and also disallowing users to not be able to actually enable public access to buckets. All of that is also getting added, So you don't leak any data without noticing, that we have seen recently in different places, So yeah, it's trying to leverage a little bit enterprise control, but at the same time providing self-service to using multi-tenancy. Yeah, and the other one that we have here is that we also see, in like object storage, like Ceph, has like a great opportunity to be like a fundamental part of lake houses. It just it makes sense. It's a natural configuration that goes together. And with Ceph, the nice thing that we have is that we have such a rich S3 API, and also the IAM API is so powerful that it's really easy to plug into all of the features that, for example, open catalogs require. So just as an example that we have here, if you're working with a lakehouse where you're using open file formats, open table formats with Iceberg, for example, you want to have some kind of governance in all of your Iceberg tables. For that, you're going to need a catalog, a RESTful API catalog, like, for example, Polaris. And Ceph is just a great match with object storage because we have the IAM endpoint, and you can very quickly just have credential vending, have per table RBAC access to the data. So we see it as a very good candidate for using it with Lakehouse, and it's also like an important part of where we're going with analytical workloads.
Yeah, and I guess one of the hidden messages or under the fold messages is we've explored carefully whether we think we need to Ceph Object should have should for example follow Amazon's S3 tables APIs to or to remain sort of aligned with the more established industry APIs coming from Apache Iceberg and related systems, and we think the latter. And we have very strong and interesting integrations with those systems that already know how to manage data sets, and as Daniel was explaining, they have tight integration and rich integration with IAM already. They can project relationships between the catalog and data sets and S3 in a more capable way than the hypothetical S3 tables APIs, and it appears like that's where industry is going. We hope that continues. So that was my name.
Yeah.
Go ahead.
No, I was just going to mention, this is the Ceph S3 vectors that we mentioned, that is really providing the S3 vector REST API that AWS has implemented, like a subset of those, making it available in RGW. The piece that is going to be behind it is LaunchDB, as Matt mentioned, and then we will also make use to make sense of all of this, we will also make use of bucket notifications. So with S3 vectors, the idea there is that you can easily have vector buckets where you have all of your vectors, and we also provide indexes. You can search through them. So it's really implementing the tools. For example, if you want to work with RAG and you need to actually save your vectors in a place, you very easily you can save your normal buckets with all of your objects, your documents, etc., and then have your vector buckets with the index that you can query very easily in the same place, everything working with inside object storage directly. Yeah, and this goes through a little bit of the event-driven kind of workflow for S3 vectors, but we will leave it here just in case if someone wants to take a look at what it would imply to have like the workflow, to get the vectors and also work with them. Yep, and if you want, this is like the D4M part. If you
Yeah, I think I pretty much covered that verbally, but this gives additional support there. D4M is our materialized cache. It's got a bunch of capabilities. We're kind of working on the MVP edges of it now, but it came from research collaboration between our team and PhD students and their advisors at Boston University and Northeastern University and what's called the Massachusetts Open Cloud Alliance. It's a big data center collaboration between universities and Red Hat and IBM. But we did a lot of work over several years. In addition to being a materialized cache that you could think of as a kind of a converged Luxio cache, we should use our vendor over there. But in addition, it did other stuff, and it experimented with a number of interesting things. One was intelligent prefetching. And there's a PhD dissertation, there's a dissertation by Aminia Abdi that talks about a student there that basically explored converging the job, the planning system, the planner and work scheduler from Spark and a couple of other data workload tools with the cache, and so that, for example, in a shared cache where multiple workloads are competing, this query system would compute a critical path between the different workloads that are going to be running simultaneously in the future. So based on that, select the objects that should be preferred to hold in cache, the ones to discard, the ones that are ephemeral, and prefetch data in time for it to be accessed, expel it in time to replace something else, and so forth.
Yep.
So
yeah, it's just going through the same.
More of that, but we'll have the first D4Ns in Umbrella, and we look forward to people experimenting with it.
Yeah, so time for questions. If anyone has any questions. Yeah, yesterday we had like the new Ceph user group, and yeah, we had like some good conversations there, especially like in other features that are there, that's like exporting into Prometheus like per user, per bucket counters, into Prometheus. That's going to come in handy because people were using kind of exporters with the usage log, that was not ideal, so that's also something that is going to be there.
If you had to use it, you know what we mean.
Yeah, and then I also learned from at the end of the room there that there's a person that was using D3N extensively, also as a cache, so they were actually pulling out the NVMEs for BlueStore, and they were leaving the nodes just with the spinning drives, and then they were putting like a huge D3N cache in front full of NVMEs, and that was giving them much better results than actually having BlueStore, using the NVMEs for BlueStore, and the metadata. So that was also interesting to learn.
Well, that's exciting. Yeah, I mean, the D3N, we rewrote parts of D3N. D3N came from a previous generation of the same work at Mass Open Cloud. We implemented a slightly simpler version of it. We focused on kind of layering and making it really fast, and a single node. Their original D3N is a rack scaled L1, L2 cache system. Our D3N isn't right now. We figured we would get to that with D4N mainly, but it's exciting to see a scale out D3N really working.
Yep, and related to the bucket scale topic that Matt was mentioning, so the idea of a single bucket growing to a huge number of objects is also related a little bit to what we saw here with the Lakehouse use case, where it's very common that a single bucket will be serving a full catalog, so you're going to have a huge amount of objects. I don't know if from the people that is here, like single bucket scale is something that will help you with your current workloads. I don't know if someone is suffering from having too many objects in a bucket with the listing being a pain, etc. If someone has an experience to share, you can get the mic there a moment and let us know.
We have some buckets with nearly 500 million objects.
500 million?
Yes, which is okay, but then they get copied over to another Ceph cluster for backup, and there the same bucket is versioned. So then we get 2 billion RADOS objects, and that gets a little bit much.
Yeah, that seems to be exactly correct. It's sort of tractable on modern equipment with SSD indexes in RADOS up to about 500 million objects, and at that point it's beginning to really fall off. Well, it's not there, but you understand.
We've had a bucket with 1.5 billion objects.
Well, you're way off. You're way over here.
Yeah, sharding was painful. It was offline.
Different subject, but we have the NFS gateway for RGW. Is there thought to doing the same with SMB?
Well, in a sense, yes. I mean, there is. I think I think there's probably talks by Gunter or his team. Gunter, are you here? I think you in our lingo we would call that multi-protocol. So yeah, I mean, to be fair though, what the distinction would be, in our NFS and RGW, we're sharing a common namespace. SMB and NFS can share a CephFS namespace with multi-protocols. They're probably not going to cross over.
Yeah, I mean, in terms of
unless
SMB gateway into RGW.
Unless Gunter wants to work on a VFS interface to RGW. It exists?
Okay.
Cool.
Yeah, I think we are already over time anyway, no? So thanks a lot. If you have any other questions, we can also take them or have a chat about object storage today and tomorrow. Please reach out and we can have a discussion on your pains or sufferings or maybe some happy stories, who knows, no? But yeah, thank you.
Yes, thanks much.